really excited to be joined today by CumuLogic. Couchbase recognizes that cloud is the new platform, and we recognize that organizations are beginning to explore database as a service as a way to kind of deploy and manage data-driven applications. So we're very excited to be partnered with them. From CumuLogic, we have Chip Childers, VP Product Strategy, and Sandeep Patton, VP of Systems. From Couchbase, we'll be joined by Todd Greenstein, Product Manager. With that said, I'm going to turn it over to Todd now.
Thank you. Again, just want to reiterate how excited we are to be partnering with CumuLogic on some of their technology. Before we get into that, I'm just going to do a brief overview on what Couchbase is, and then we'll turn the floor over to Chip. So Couchbase, currently, we're the fastest growing NoSQL database company. We've experienced 4 times growth in 2013, and we're widely recognized as an industry leader. We provide a key value and document database for web and mobile apps. 2014 was a big year for us. We finally deployed our Sync Gateway, which is something we're super excited about, and we've been spending a lot of time developing on. And it's great to have that into the market. We've got excellent feedback, and a lot of customers are using that now. We are the leader in scalability and high performance. Basically, everything that we do is based on a single node type, which allows us to experience this incredible performance numbers that you'll see often posted and people talking about with Couchbase, and allows us to scale really easily. We're the only NoSQL vendor with a mobile database and a Sync Gateway, and that largely we've been recognized heavily in the industry as a leader in this space. And mission-critical deployments and large enterprise internet companies, we have over 400 customers today. Wide customer base with strong growth in European and Asian markets. Currently, we have over 150 employees. Our engineering centers are based in the US and in the UK and in India. And we also have offices in Japan, and China is coming along soon. So you'll see here the market adoption of companies that are currently using Couchbase. Early on, there was a lot of sort of internet-related companies and early adopters and people that were willing to take a bit more risks on new technology in things within the NoSQL space. And as we've seen this market sort of mature, we've seen a lot more of sort of the old blue chip type enterprise companies come on board and are very interested in NoSQL. And more often than not, we are being chosen as the vendor of choice within this space. What is Couchbase? So our basic overview, the tenets of our product are: we're a high availability cache, we're a key value store, we're a JSON document database, and we're a mobile device store with a Sync Gateway. We offer the full range of data management solutions depending on your needs. What makes us the best solution on the market is our ease of scalability. One of the great things which allows us to partner with people like CumuLogic is our ease of scalability and our single node type that I mentioned previously. It allows us to scale with just a click of a mouse or a simple REST call or a simple command line call, and we can add additional nodes into a cluster very, very easily. We're consistently high performance, sub-millisecond latency for reads and writes, and the reason that we do that is we utilize a smart client, which makes us strongly consistent, makes us one of the only strongly consistent databases within this market space. And by doing that, we do all of our hashes from the client, and without getting into too much detail here, it basically allows for our extreme performance that you'll see posted frequently. We're always on 24/7, 365, and what that means for us is everything that you do in Couchbase is an online operation, whether it's rebalancing and how you move partitions around to optimize a cluster, or if you need to do upgrades or maintenance or take nodes out, add nodes in, it's always an online operation. You never have to take the database offline. Flexible data model, we are a JSON document at our core, and that allows you to basically build applications and have this flexible back end, able to model things in JSON data and work in objects as you would from your IDE. Ease of scalability. So for us, we auto shard. By default, we shard into 1024 virtual containers that we refer to as vBuckets. You don't ever have to manage the sharding. It all happens automatically, and this is all distributed among all of the nodes in a cluster in an even manner. Cross data center replication, which you'll commonly see referred to as XDCR. This allows us to replicate cluster to cluster, and this is a great solution for durability and high availability, and also for offline reporting. It allows you to basically replicate your data store to a remote cluster somewhere that does not have to match your primary cluster in size and performance, and it allows you to have this great solution for disaster recovery or for geographical replication of data. And our single node type, again, this is the core of our architecture and allows us to, and allows people like CumuLogic to leverage the power of Couchbase by having this single node type. It makes us very, very easy to administer and cluster. We're very popular in the DevOps space because of this. And we're consistently high performance. We support massive concurrent connections. The way that our smart clients work with threading model, and you'll see coming out in the 2.0 versions of our SDK, is actually an improvement on this, we're actually supporting reactive extensions in the Java client library. That said, currently we have fine-grained locking. We don't ever lock you out from reads unless you choose to use pessimistic locking, which by default everything happens through opportunistic locking, so you're never locked out from reading. We support CAS, which is you'll see commonly referred to as check and set or compare and swap, and this allows us to have some very, very interesting high throughput and high velocity data applications. We're built-in cache. When we talk about layer consolidation, we basically take the cache and the persistence layer and we combine that into one space, which can give you an extreme performance advantage when you're designing high performance applications. And hash partitioning, I touched on this previously. This is we use a CRC32 algorithm from all of our smart clients to figure out where to write and read data from on the cluster. So we don't ever have to shadow requests through or proxy requests from node to other nodes within the system. And again, always on 24/7. So if you ever have to online do any type of maintenance to a node, it's very easy to remove a node and add another node back in its place. As far as administration operations, those are always online, whether it's compaction, indexing, rebalance, backup, restore, always online. And with the 3.0 release of our product, which comes out on October 6th, we actually support incremental backup and incremental restore as well, which is a first in the NoSQL space. And high availability for replication and disaster recovery. Currently, we support auto failover, which has a 30-second window for minimum, and during that time period, with the 3.0 release of our product, we're actually able to queue up in-flight data and ensure that you don't lose anything for writes during that time frame. Again, we talked about the cross data center feature, so I won't go into that again. And flexible data model. So when you're developing applications, it's great to be able to have a schemaless, unstructured, or semi-structured data. And I like personally the term flexible schema better than schemaless for the fact that you're able to, if you're used to working in objects, you can do that here as well. And, we maintain that same object representation that you'll use within your IDE that you'll see in Couchbase. And we're able to handle these changes very, very efficiently with the way that our protocols are established within the system. Now I'm going to go ahead and turn this over to Chip, and we'll learn a lot more about CumuLogic.
Thanks, Todd.
So let me, okay.
All right, fantastic. So we can go ahead and get started. Thanks again for that overview, Todd. Appreciate it. So let me introduce CumuLogic. CumuLogic is a software company that offers a platform that allows enterprises to create a database as a service environment on-prem. And that on-prem idea is actually really important to us. So on-premise database as a service should be operational automation of the delivery, deployment, as well as the management of the database. We really want to make data services as simple as possible. And kind of the analogy that we've come up with for CumuLogic is, it's kind of like going to Starbucks. Starbucks has done a great job of figuring out how to make the act of getting potentially complex caffeinated beverages very easy. So for us, it's kind of a question of coming in and saying, pick your database flavor, and we pick Couchbase, and you size the database deployment both in terms of the nodes as well as the number of nodes of the cluster that will be deployed. You could make some optimization selections, things like tuning specific configuration values for the nodes before they're deployed. And there are also some add-on services that our platform supports. And then last, you then pick the infrastructure that you want to run it on. And the way our software is designed, we're able to work with a large number of different infrastructure options. We can work with a private cloud that's on-prem. We could work with an OpenStack environment. We can work with VMware-based environments. We can also work with pools of either bare metal machines or virtual machines that are on the network waiting for us to push the application payloads. And just as interestingly, we're able to work with really any public cloud as well. And our controller can give your users choice in where the application is going to be deployed based on what the administrators configured as the target cloud options. So we make it very simple. So now the question is, well, why? Why database as a service versus going through the process of installing each new cluster? Couchbase has done a wonderful job of making the installation and the operations of their engine very straightforward. But what we're seeing in the enterprise is that really when you look across all the different application teams that are inside of your organization, there's a lot of application-specific database deployment going on. And so there's this need to come up with a way to consistently deliver to the application teams the right database in the right infrastructure at the right time, and then to really take it to almost zero operations. Obviously, we're seeing massive growth in overall stored data. There's an increase in velocity of change in the applications, especially systems of engagement. Anytime you're dealing with maybe a line of business operational tool, or you're dealing with a marketing-related application, you're going to see a lot of change occurring. And that means there's a lot of activity up and down the stack, deploying new staging environments, deploying new test environments, deploying a change to production. So having a self-service way to do that is really valuable. And then in some companies, there are some challenges in supporting, operationally supporting newer technologies. And if it's largely automated in your behalf, then that takes a lot of the challenge away. And then last, the real question about why on-prem database as a service is interesting are questions of data governance, locality, sovereignty. There are public cloud database as a service services that you can go and give your credit card and sign up for. That's great, but then the question is, where's the application? Where are you running the software that's communicating with that database environment? And being able to have a platform of your own that lets you deploy these database systems on-prem into a production environment. You might use public clouds for dev and test or load testing. It gives you a lot more flexibility in deciding where the system is going to reside. So our basic value proposition for you is that we automate 75 to 90% of the operational tasks around provisioning, change, maintenance. That reduces costs, that reduces risk. Risk specifically because it's fully automated. And when something's automated, it's going to be consistently done. And you don't necessarily have the risk of two different administrators deploying the same software and potentially seeing that be done in a different way. The second is that we think that developers need to be empowered with access to these engines. And we do offer a couple of different database engines within our platform. And we think that choice is really important because some are stronger for other application types. And you might want to have a relational database as part of your stack. You might want to have a document-driven system like Couchbase. And giving those developers that easy access to multiple engines, let them self-serve, it frees your DBA team and allows them to really become kind of the owners of the whole data landscape for your company. And they can become more valuable for the application teams and can serve as experts in how to actually use the systems that are being deployed. And just as important, maybe data already exists, and what's the right way for the application teams to work to leverage existing data sources. And then the last is, of course, we run on any infrastructure, and I made a point of that earlier. This is really important. There's always a lot of existing infrastructure investment in place in any enterprise that's been around for more than a few years. And being able to work with that infrastructure, work with newer private cloud builds, work with public clouds, that gives you a lot of choice and a lot of flexibility. So let's focus specifically on the module of our platform that's dedicated to NoSQL services. And what we've done is we've built this module to operate in a way that's very analogous to Amazon's RDS capability, except of course we're talking about NoSQL engines, not relational databases. So what CumuLogic does is it gives you this web-based or API-driven method of asking for a new cluster to be built for you, to do things like size the nodes, scale it up in a self-service way, scale it back down again. It's very simple to deploy. Our software is very straightforward. We can deliver it in a virtual appliance form factor, or you can have an installer when you want a high availability controller environment. Reliable, and it's cost effective. And we do support multiple engines. We'll focus on Couchbase today, but we support multiple engines for the NoSQL service. So focusing on Couchbase, if you assume that that's the premise is an RDS-like experience for getting a database engine deployed, specific to Couchbase, right now we're supporting the Couchbase Server version 2 series. We're working to implement support for version 3. As you heard earlier, that's going to be released out of beta shortly. And so we're working to make sure that we support that. We can allow users to deploy anything from a simple single node standalone environment that's very useful for quick development tests, but then you could take that same environment, you can scale it up to n node clusters, or you could start with a cluster. We also handle a certain level of automatic node recovery and cluster self-healing, and this is one of the areas that we partner with the database engine that's being deployed, in this case Couchbase, to make sure that Couchbase is going to maintain availability through its knowledge of where the data is, how it's replicating data between the nodes, but we're going to, behind the scenes, handle a node failure by bringing a new healthy node back into the cluster and rejoining it, and then making sure that the Couchbase server is aware and it's able to begin to rescale once that new capacity is added back online. We also handle automated file system-based backups. We do this based on LVM snapshots, and we'll coordinate that across the cluster for you. It's scheduled on the user's behalf if they choose to opt in, or they can execute that on demand, again, API call or self-service. We integrate with some application performance management tools as well, in addition to some of our internal monitoring functions. So when I show the demo today, what you'll see is a dashboard that gives you some performance information about the deployed nodes in the cluster for every database instance that's deployed. But we also tie into AppDynamic and New Relic, so any new system being pushed out into your environment is automatically being added to either one of those SaaS-based offerings. And the other thing we are is we're both data center and cloud and availability zone aware. And because we support multiple cloud types, the user is going to get to select which general cloud are they going to target. And then within that cloud, if there's a notion of availability zones, they can then select which availability zone that they'll be communicating with. In our demo, we'll be using Amazon EC2 as the example, but the same thing applies really to any of the private cloud software that's out there. A little bit about our roadmap. I mentioned earlier we're going to be adding support for Couchbase Server 3. We also have support for automatic minor version updates. That's going to be coming very, very soon. That's actually in testing with one of our large customers right now. We'll enhance support for deployment of the Couchbase replica nodes. We've been working with Couchbase to understand a bit more about the technology and some best practices, and we'll be adding that to the way our platform deploys the clusters on your behalf. The other thing that's interesting is Couchbase's XDCR technology. In the relational database module for our software, we support multi-zone replication and automatic failover of the environment, of the applications over to the secondary location. We'll be working with Couchbase to make sure that we can do the same thing for Couchbase using the XDCR tech. Additional scheduled maintenance tasks that we'll be bringing into our self-service functionality includes executing the rebalancing and compaction operations. Also, we'll enhance our features around bucket management, monitoring. We think the sync gateway is very, very promising as well. The reason why our customers are asking for Couchbase very frequently it tends to be around a mobile application environment, and we think the sync gateways are fantastic And our goal is to make adding a sync gateway to either an existing or to a new Couchbase cluster that's being deployed as simple as checking a box to decide that you want to add that function. And the last thing we're going to do is we're going to enable an advanced feature that can let users that might be communicating with the Couchbase cluster based on a client that isn't one of the smart clients. So we'll enable the server-side Moxie. Briefly, just take a look at two slides that explain a little bit about the CumuLogic architecture. This one is the deployment architecture, just so you get it very simple. You can see in a very simple way. We, number one, are not in the data path between applications and the database. We operate as a control plane for the environment. So I mentioned earlier that our software is available in a virtual appliance format. That's perfect for either small team usage or for proof of concepts. And you can grab that virtual appliance. It's a single management server. It's got an internal MySQL database ready to go, and then you point it at a target cloud environment. You give it API access, and then the users give it their credentials into that target cloud. Now, of course, once you move into production, people start relying on the service. We move to an end node architecture that externalizes that metadata database that we've got, but it's the exact same experience for the end users. Because we're not in the data path, a single one of our controllers, in fact, a small virtual machine version of our controller can scale up to 20 target clouds and thousands of virtual machines. And we're actually, again, because it's control plane, the main scaling factor for us is the monitoring telemetry that we're doing, both for ensuring that we pull back data about performance and capacity in the deployed environment, as well as maintain that health check to do the automatic healing that we need to do if a node becomes unhealthy or if it goes offline. This drills in a little bit more into some of the details. We won't spend a lot of time on it except to highlight three major areas. So the first thing I'm going to talk about is that the way that CumuLogic works with the infrastructure is that it will either have access to an API that can be used to provision the appropriate virtual machines, networking, and block storage that's needed to then install the application within, or it will look at a pool of kind of pre-created systems that are either bare metal or virtual machine. They're sitting on the network and they're waiting for our controller to push application payloads to it. But what that lets us do is that in either case, we can take any node that's been created and push the appropriate application bundle to it. In this case, this would be the Couchbase Server process. When we add the sync gateway services, we'll be able to push a sync gateway to its own nodes in the environment. And we have a few other software bits that sit on those systems. One is a CumuLogic agent, again, our monitoring sensors, and then any third-party agents that you might need. And I mentioned AppDynamic, New Relic. Those are the two use cases that are able to be orchestrated by our controller. But we also have a number of different companies that have used the fact that we start with sort of a master image, and we push software on demand, and they've been able to integrate with on-prem monitoring software they might have. They've been able to integrate with their own backup solution if that's what they'd prefer to do. So we give a lot of flexibility in how things are handled. The last thing I'll point out, because I already touched on the APM integrations there, is in the lower left-hand corner. We talk about how we actually deal with storage of the control data itself. Now, for us, what this means and what's important is that we maintain some metadata about what's been deployed on behalf of the user, but what's really important is what are we going to do with any backup that we actually pull back and pull back from a deployed database instance. And so what our controller is able to do is either work with locally mounted block storage. Typically, this is an NFS share that might be mounted across all of the controller nodes in our architecture. Or more interestingly, we're able to deal with both the S3 API as well as the OpenStack Swift API. And so if you have object storage available, that's where we can actually push off any of the nightly snapshots that are done. And so with that, I'm going to switch over to my browser and give you a quick walkthrough of the product itself. So what you see when you first log into the CumuLogic dashboard, and this is the end user experience, so it would be the application owner or the operational person who wants to actually provision the instances, not the operator who's managing the CumuLogic software. And what the user gets is a quick dashboard that tells them how many databases might be running, either SQL or NoSQL. There's the notion of a subscription. This is a simple service catalog. In an enterprise, you may choose to have some sort of dollar figure tied to the deployment for the purpose of chargeback, although that's completely optional. And really, it's just a display label. But we make it very, very simple for the operations team to decide what is the service catalog going to look like. And at the same time, the users can choose to use that catalog, or they can choose to customize what their own deployment is going to look like. And I'm going to walk through both of those scenarios. So in this environment, I have a 3-node Couchbase cluster set up as a possible subscription. And I've got a very simple launch button. I can name my cluster and click launch. And that's all I really have to do. And now this CumuLogic controller is going to go through the process of actually establishing all the virtual infrastructure we need, pushing the Couchbase binaries, pushing the configuration, orchestrating the nodes to join together into a cluster, and then kicking off all of the scheduled jobs that need to be scheduled around backup services and monitoring functions. And so we'll let that build. That's deploying in Amazon right now. The other thing we're able to do, though, as an end user, and you can get to this from the dashboard as well, is effectively go through the exact same process, except answer the questions for yourself. So we'll walk through this just so you understand some of the features that are there for the provisioning choice. So first thing we could do is, again, we can name our cluster. We could describe it if we'd like. This is where you then get to select a type of engine, and so we'll pick Couchbase. You then pick your target cloud. In this case, we'll pick EC2. Now, the operator of this CumuLogic controller has decided what target clouds are available, and that actually is also true for what availability zones within that target are available. In this case, we've just got Amazon EC2, US East 1 established, but you can imagine that list including private cloud infrastructure East Coast, private cloud infrastructure West Coast, or pool of virtual machines that's sitting in my local data center. It can really be anything, any pool of infrastructure that we'll be able to provision into. Next, depending on the type of cloud that you selected and depending on what the administrators decided is going to be the appropriate set of instance types, we'll let you select the size of the nodes, and that'll have to do with the amount of CPU and RAM the node will have. We'll get to the data volumes in just a moment. Service tags are very useful when you're communicating with our controller through its API. They allow you to identify the phase of the life cycle that this instance is part of. So you imagine a complex application team. They've got lots of development instances out there. They might have QA. They might have staging. Then they have production. They might even have a disaster recovery node or deployment out there. So service tags let you kind of arbitrarily tag any of the deployed instances, and then you can use that when you're interacting with us. Access groups are the network rules that are going to govern the firewall policy into and out of that cluster. If you don't choose anything, because you can see it's not actually required, the controller comes with a set of default ACLs that are going to be pushed, and the administrator can tweak those if they'd like to be specific to your environment. However, the users themselves can create access groups that they want. They might, for example, only be dealing with a team in a particular region of their company, and they only want access from the application tier that's going to work with the database. So they can establish their own access groups and then apply it to the nodes that are being deployed. You can see here that we've defaulted to one node. It's very easy for us to grow this cluster. I can select up to 4. I can kind of keep going. As many nodes of the Couchbase server that you want to join together into a cluster as you'd like. You can select that. The controller will handle it. Once we've deployed, I'll show you that we can easily add a node to an existing cluster as well. Then you get to kind of do some initial setup of buckets in the environment. This is just to get you going. You get to select potentially character sets and the port that the service will listen on. A parameter group is a way that you can fine-tune some of the configuration around the engine itself. Use cases for this vary between companies, but it's really kind of the idea is that everything shouldn't be hidden from you. There are some configuration values that you as a user might want to manage, and so that's a way to accomplish that. Within the storage and backup area, this is where we start thinking about how much data needs to be stored in each node of the cluster. And so you can do really anything from 10 gigabytes and up. It's going to depend on the infrastructure that you're going into, the type of options you can get here. But in this case, we're going to EC2. We'll just ask for a 10 gig EBS volume to be attached to each node. I can then enable backup services for the cluster. That allows us to then set a retention period. This could be, in this example, maybe 20 days worth of snapshots are going to be retained. We can decide what time of day the backup will actually occur. We can enable the maintenance window. This maintenance window is actually common to all of the databases that we deploy. It's going to be used by that automatic update feature. Now, because Couchbase is does a very elegant job of how it handles version updates within the deployed engines, this will operate potentially a little bit differently for Couchbase from some other engines that we have. But in any case, you still may want to choose the time that you're going to do the upgrade process, because as the Couchbase server or as that Couchbase cluster is doing its update, it potentially is shuffling some traffic around, shuffling some data around. And with that, I would just click submit, and it would kick off the process of provisioning. I'll cancel that because I've already provisioned, and I don't want to wait for EC2 to get around to giving me my virtual infrastructure. As you can see over here in the cluster that we deployed at the beginning, it's going through the process of asking for all of the compute infrastructure that it needs, configuring DNS services for each one of the nodes. It looks like it's about to move into the phase where it pushes the application payload and gets the service up and running. But taking a look at the cluster that we deployed just prior to the webinar here. So this is a deployed cluster. Some very basic actions we can take for it. We can modify it, which means we could, for example, I did not opt in to schedule backups, but I could at this point. I could also tweak the parameter groups. Or just saying modify this configuration and wait for the next maintenance window to apply. And so that gives you some flexibility for when the changes occur. I can restart the entire environment. That will effectively just go through the entire service and all the virtual machines and initiate full restarts and make sure that everything's nice and fresh. We can terminate the whole environment. That'll tear everything down. It will destroy the virtual infrastructure. And it will retain the metadata that describe the type of cluster, the sizing, the storage, the target cloud that you're going to go after, so that you could redeploy a fresh environment if you'd like. For scaling, adding a node is as simple as saying add nodes. It'll ask you to confirm, and it'll add a node to the cluster on demand. The other interesting thing we can do is actually initiate a clone of the entire environment. We found this to be particularly useful when you're dealing with a production data set and you may be about to roll out a new version of your application and you'd like to do final staging tests, or you'd like to do some type of QA testing against a full copy that replicates not just the configuration but also actually has all of your production data in it. And so when you initiate a clone operation, we'll take the state of the whole cluster, we'll initiate a backup of all of the nodes, we'll recreate a fresh environment, and then we'll restore all the data into that fresh environment. And you'll be able to, at that point your new application version to it, maybe do some testing, and then you could just terminate that test environment if you'd like. I already pointed out the Events tab. This is really just giving you some visibility into all of the automatic configuration that occurs during provisioning, as well as any of the automatic health activity or backup activity that's happening on your behalf within the controller. You also get a view into the access details for the cluster. This will point out all the various nodes, just let you know what the access credentials are. Because we're in EC2, you get a little bit more information about the public, both IP, DNS names, as well as the private IP and name that the underlying instance received when it was booted. Snapshot management, this is very straightforward as well. We can create a snapshot. You would select the cluster that you want to do a snapshot from, you would name it, and you would say create, and it would go through the process of snapshotting that cluster for you. Oops. I can also restore from snapshot. You could do that really by selecting the snapshot in the list. And in this list, what you can see, we've got a couple of automatic backups that are stored, but we also have a manual snapshot that I had initiated on demand. And so I can restore from any one of these. I can also delete them. So especially for the one that was done manually, the retention period policy doesn't apply to the manual snapshots, and so you want to go clean them up once you're done, and you trust that whatever changes you are making, or maybe data migrations from one format to another are effective. This gives you a way to then clear that out and move on. I mentioned earlier that we do support a basic level of monitoring. While we integrate with New Relic and AppDynamics, this monitoring data is useful because it can give you a consistent visibility, especially if you don't have New Relic or AppDynamic. It can give you a view into the performance of the cluster. We'll show both really a combination of performance data that's specific to the operating system and really the VMs themselves, as well as things that are useful within the context of Couchbase explicitly. And for any one of these things, you could, for example, take a look at CPU total usage across all the nodes. You can change the total volume of time that this is plotted against. You can see all three nodes of the cluster are visible, and you can get a feel for which nodes might be highly active versus not. I mentioned parameter groups and access groups already. And so again, both of these are ways that you can configure either specific configuration values for Couchbase, or within access groups, define the network policies for how the deployed databases are going to be firewalled. And with that, what I'll do is I'll switch back here and pull up some notes that talk about additional information. If you'd like to contact CumuLogic, you can email us at info@CumuLogic.com, or you can go to CumuLogic.com and get access to a sandbox environment, trial versions, or just learn more about the service itself. So with that, Shane, I'll hand back to you and see if we have any questions from the audience.
Thank you, Chip. Thank you, Todd. We do have a handful of questions, so we'll do our best to get to all of these before we finish today. The first one probably isn't too much of a surprise. Docker is a pretty hot topic right now. Do you plan to support containers as an underlying infrastructure for deployment?
Yeah, that's a great question. So I mean, obviously today I talked a lot about virtual infrastructure and really the VM as being the unit of isolation. I also talked about pre-provisioned systems and, again, bare metal or virtual machines. We are actually working to make Docker containers the unit of deployment, and that'll do two things for us. First, it's going to let us work in environments where you might have a cluster of Docker hosts available, and then we'll be able to in a more fine-grained way carve up the target infrastructure that we're working with, and to allow sizing flexibility and some of the resource constraints that Docker allows to take effect within that bare metal pool environment. And secondly, we'll switch to that being a consistent model for software deployment. I mean, today we're pushing the application payloads out there. It works extremely well, but since we'll do the work to deal with pools of Docker hosts, we're going to do the same thing and take the exact same approach for deployment when we're dealing with a public cloud infrastructure. And so we'll still think of the virtual machine as being a unit of isolation. However, we'll allow those VMs to then host a single Docker container so that you have kind of consistent operational experience in what's deployed.
Great. A follow-up question of that, and this is particularly relevant to Couchbase Server being a distributed database. How do you plan to handle networking between the containers? Would you use something like Weave?
That's a great question. We are still early on in our process of engineering how we're going to work most effectively with Docker in this environment. I think that it's likely in the initial scenario we'll be dealing with a much more simplistic approach. We'll likely just bridge all the containers to the underlying network that's there. It's likely that Weave looks very attractive. The Weave technology is still young, right? It's still early, but it does solve a lot of problems effectively by creating a very, very simplistic kind of mesh that allows you to think about kind of the way that the Docker containers are communicating with each other, as well as into and out of that deployed environment. So it's a possibility. I can't necessarily commit to how we're going to approach this yet.
Thank you. Next question, do you have policies for auto-scaling software, whether it's applications, databases, maybe in its extension of that, what can be done with policies? How can people leverage them?
Yeah, that is a great question. CumuLogic actually has been around for a little over 3 years. We started as a platform as a service company before, really kind of focusing on this data services use case. So what that means is that we've got a well-tested auto-scaling engine within our platform. But what we haven't done is productize database auto-scaling. We have gotten a request a few times, and it's going to really depend on the database itself and whether or not it's able to support some level of auto-scaling. Now, the other thing to keep in mind with databases is that auto-scaling really is going to happen ideally across 2 vectors. One is going to be capacity, right? So as your cluster gets more and more data pushed into it, you might need to scale that cluster by adding nodes based on capacity reasons. The second reason, though, could just as very well be due to traffic, number of I/O operations per second, reads, writes. And so we've got logic that can support both. It's very likely that Couchbase would be the first database engine that we would do an auto-scaling function with. So not today, but because of the value of Couchbase, we're looking forward to seeing how we can do it with Couchbase.
We're looking forward to it as well. The next question is, what monitoring tools will work with CumuLogic?
Great question. So I mentioned 2 of them earlier. One of them is AppDynamics. One of them is New Relic. And those are the 2 SaaS offerings that we'll integrate with and we'll actually orchestrate with. But I also mentioned earlier that our current model of allowing third-party agents to be in what's called our master image, the image from which all of the instances that are being created at runtime comes from. We allow the end user, or really the customer, the administrator of the CumuLogic platform, to say, these are the additional software agents or software packages of any type that can sit in that master image. So when the VMs are being booted, it might have really any monitoring software that needs to run as an agent within it. The other thing that you can do, because we're not in the data path and we're really not getting between the application and the nodes themselves, is that you can really take any monitoring package that's out there or backup software that is able to work with a remotely deployed system, just communicate with it over the network. It might be an SNMP probe. It really could be any type of monitoring system that can just use network access to interact with the environment. And as long as your network ACLs are going to allow that system to communicate with the cluster, it will have no problem doing that.
Thank you. This next question is for Todd. How are Couchbase customers thinking about leveraging cloud infrastructure, if they are?
Good question. This is something that comes up a lot. Obviously, I think about 60% of our customers today are deployed in some form of off-prem cloud-based technology, and 40% are on-prem cloud technologies. And everyone's always looking for a better way to implement that and to manage that without having to live in scripts all the time and come up with their own homebrewed infrastructure to do that. So tools like CumuLogic are going to be a big advantage to customers that are trying to do these types of operations.
Thank you, Todd. For Chip, can developers still use the types of DevOps tools they've used previously, whether it be Chef or Puppet or things like that?
Yeah, so that's an interesting question. So I think in this particular case, we do eliminate the need for Chef and Puppet to participate in the database deployment process, because we've taken what Chef and Puppet do, which is a declarative description of the configuration of that deployment, and we've effectively abstracted to a higher level. And so now to get this type of database deployment, it's an API call away versus kind of roll your own definition of the configuration of the cluster. So that's that's kind of the way we think about Chef and Puppet. Now, truth be told, there's potentially some value in thinking about how a tool like Chef Knife could work with our API to let the operator ask for a new Couchbase cluster and get it, in much the same way that it's able to, request a new virtual machine. The difference there, I think, would be that it doesn't have to go through the process of pushing the Chef recipes into the nodes. It just knows that it's been established on their behalf.
Thank you. This question is probably for both Todd and Chip. To what degree would management take place in CumuLogic versus within Couchbase Server?
I can start with that. Obviously, your data, your DML and DDL type functionality is always going to remain at Couchbase. Your things like scaling and deploying of infrastructure and things that actually Couchbase will live on, that's above and beyond us.
Yeah, that's the same way I would answer it. We're very focused on making sure that that basic level of operation for provisioning and the basic management functions are in place. And then once you've got that deployed, how you use that database is then however you'd like. You can take the Couchbase management tools and attach it to the deployed clusters in just the same way you would if you, for example, had done all of that work by hand.
Great. We have one last question before we wrap things up here, especially in the context of as a service, and in our case, database as a service. How would organizations approach the concept of multi-tenancy?
That's another very good question. So the way that CumuLogic has approached that is that today we think of that virtual infrastructure as being the unit of node isolation. Now, when I requested the new cluster in the demo, what was actually occurring was that my personal API credentials to work with EC2 were what were being used to request the VMs. So, we of course have a notion of multi-tenancy, and that more than a notion, we have multi-tenancy in that every user has their own account in the CumuLogic controller, and they either have been granted the right to plug their API credentials into a particular target cloud that's being offered to them by the administrator, or they have potentially, in some cases, they've been given the API credentials that they'll be using. And so what that means is you've got a lot of flexibility in how you think about your target environment. So our approach to multi-tenancy is that it's not necessarily in database multi-tenancy, which Couchbase has a lot of great features, ways that you can secure various parts of what's happening inside the cluster. We deal with the multi-tenancy of multiple clusters and letting users deploy as many nodes or as many discrete clusters or as they need. So depending on how many applications they're working with, what stage each application is in the life cycle, and between the various users, they each get their own instances that are being deployed, and that's occurring within the context of their tenancy that they've established within the underlying infrastructure target.